Good morning. Today I am here to discuss about NCERT's Grade 10 Mathematics Chapter 1 Real Numbers. So, before moving on to our topic, let's discuss about numbers. Just a brief discussion. We know that there are different types of numbers, like natural numbers, then whole numbers, integers. Okay. Natural numbers. Let's denote natural numbers with letter N. We know that what are the natural numbers? 1, 2, 3, 4, etc. Let's denote whole numbers with W. Whole numbers is natural numbers with a 0, isn't it? Whole numbers are natural numbers along with a 0. Then what are integers? We have learned about integers. What are integers? Integers includes both negative and positive numbers. Integers include both negative and positive numbers, that is whole numbers and the negative of it, that is integers. Okay, then we have learned about rational numbers. Rational numbers. What are rational numbers? Say in the number line, for example, if this is a number line from 0 to 1, there are some other numbers in between this, like this is 1 by 2, then this will be 1 by 4, this will be 1 by 8, etc. So, rational numbers are those numbers in fractions, or in general we can say rational numbers are those numbers that can be written in the form P upon Q, where Q not equal to 0. Clear? Rational numbers are those numbers that can be written in the form P by Q, where Q not equal to 0. Okay? Then irrational numbers. Irrational numbers. What are irrational numbers? We can give some examples like root 2. Root 2 is an irrational number. Root 3. They are irrational numbers. So, irrational numbers are those numbers that cannot be written in the form P by Q. Irrational numbers are those numbers that cannot be written in the form P by Q. So, I hope you got a clear understanding about the different types of numbers and how we can identify the different types of numbers. So, in this chapter, we are mainly dealing with Euclid's division lemma and fundamental theorem of arithmetic. Euclid's division lemma and fundamental theorem of arithmetic. These are the two main topics which we are going to deal in this chapter. So, let's move on to Euclid's division lemma. Okay. Euclid's division lemma is not a tough thing. You just need to have a basic understanding. You just need to understand the concept behind this. Then it will be very easy to understand. So, let's get into this topic. Euclid's division lemma. We all know how to divide two numbers, isn't it? We all know how to divide two numbers. So, let's divide 10 with 3. What we will get? 3 times 9 will get a remainder 1. Right? We know that here 10 is the dividend. 10 is known as dividend. 3 is the divisor. 3 is the divisor. 3 is known as the quotient, and R will be remainder. 10 is the dividend, 3 is the divisor, here 3 is the quotient and 1 is the remainder. That's clear? So, we know that from this equation, from this form, we know that dividend equals divisor into quotient plus remainder. Am I right? I'll write it down here. Dividend equals what? Divisor into quotient plus remainder. Is it clear? We'll check it out. 10 equals divisor into quotient plus remainder. 3 into 3, 9 plus 1 is 10. So this concept is clear. Dividend equals divisor into quotient plus remainder. Okay. And one more thing, in this, from this division, we can understand that dividend will be greater than divisor. 10 is greater than 3. So dividend will be greater than divisor. And the remainder will be always less than divisor. Dividend will be greater than divisor and the remainder will be always less than divisor. Okay. We'll give some variables and we'll put it in a general form. So, for dividend, let dividend be A. I'll use the variable A. Dividend be A. Divisor be B. Quotient, as usual, we will put it Q. And remainder be R. Then how will make it in a general form? Dividend A equals divisor into quotient plus remainder. We know that dividend equals divisor into quotient plus remainder. And one more thing we have noticed that here remainder should be greater than or equal to 0 and it will be always less than divisor. Divisor means B. 0 less than or equal to R, less than B. So this is our general form. We have put it in the general form. Okay. I hope the concept is clear. You can just note it down here. Dividend equals divisor into quotient plus remainder. To have a clear understanding, you can just note this example on the side, on your right hand side of the book, and the concept will be very clear. A equals B into Q plus R. 0 less than or equal to R less than B. Okay. So from this we can understand that for any two positive integers A and B, there exist another two positive integers Q and R satisfying A equals BQ plus R, where 0 less than or equal to R less than B. Is it clear? Okay. From this, we got an idea that we are given two integers, two positive integers A and B. There exists a unique integer Q and R which satisfies A equals B into Q plus R, where 0 less than or equal to R less than B. This is the whole concept of division. Okay, is it clear? Okay, then now we will move on to Euclid's division lemma. What is this lemma? Euclid, it's the name of the scientist who developed this. Division, we already know what is division. Then what is lemma? Lemma is just a proven statement for proving some other statement. We can even write Euclid's division algorithm. You might have heard about algorithm. Algorithm is a set of defined steps to get into a solution. Okay. Lemma is just a proven statement for proving some other statement. Here we have one statement A equals BQ plus R. We are using this statement to prove some other statements. So mainly Euclid's division lemma is used to compute HCF, that is the highest common factor of two numbers. So we will be using this equation. On the basis of this equation, we will be finding out the HCF of two numbers. Okay, that is Euclid's division lemma. We'll move on to a problem, then it will be more clear to you how this Euclid's division lemma works. I will make you understand with the problem. That will be more easy. Okay, let's move on to the problem. Okay children, listen carefully. I will show you how to find out HCF of two numbers, or what is an HCF is, highest common factor is. You might have studied in your previous classes, but still I'll put some example and I'll make you understand what is HCF. So find the HCF of 12 and 18. I have taken two small numbers, 12 and 18. First we have to find the factors of 12 and 18. How we will do? First we will take 2, 6, 2, 3, 3, 1. Okay. 18. 2, 9, 3, 3, 3, 1. We will be doing until we get 1. Right? So we are doing. So 12 equals, how we can write 12? As in factors 2 into 2 into 3. And 18 equals 2 into 3 into 3. We have to find the HCF. HCF is the highest common factor in these two. Which is the highest common factor in these two? 2 is there and 3 is also there. So HCF will be HCF of 12 and 18 will be 2 into 3 equals 6. Or HCF is the least power of common factors. Least power of common factors. Here it is 2 square into 3 and here it is 2 into 3 square. So the common factors with the least power. Here it is 2 square and here it is 2. 2 raised to 1. So we will take 2 and here it is 3 and here it is 3 square, right? 3 into 3, 3 square. So we will take least power, which is 3. That is 2 into 3 equals 6. Is it clear? So HCF of 12 and 18 is 2 into 3 equals 6. Okay. So you know how to find the HCF of two numbers now. Then how we will use, next we are going to discuss about how we are going to use Euclid's division lemma to find HCF of two numbers. We will be getting some big numbers. So how we will be using this Euclid's division lemma to find the HCF of those two numbers. This is what we are going to discuss about. 12 and 18, we have taken HCF of two numbers, 12 and 18. What we are, first I will do all the steps. We'll discuss in detail. Then we'll go to the steps. Okay. I will make you write the steps afterwards. First we will do this problem. Here HCF of two numbers 12 and 18. So what we have to do is, from these two numbers, pick the biggest number and divide it with the smallest number. So here 18 and 12. So I am going to divide 18 with what? 12. I am going to divide 18 with 12. Then how many times? 1, 12, 6. Then how I can write it in the form dividend equals, this is our standard general form, dividend equals divisor into quotient plus remainder. This is our standard form. So, how we will write it from here? Dividend 18 equals 12 into 1 plus 6. Okay, 18 equals 12 into 1 plus 6. See here, here the remainder is not equal to 0. We got the remainder as 6. Here r not equal to 0. R equals 6. Therefore, r is not equal to 0. Then what we have to do? We have to again do the division by taking these two, 12 and 6. 12 means that is the divisor and 6 is the remainder. We have to again do the division with 12 and 6. Taking the biggest number as dividend and smallest number as the divisor. Why we are doing like that? Because the remainder is not equal to 0. Then we have to again continue the division by taking the divisor and the remainder as dividend and divisor. So, 12 divided by 6. I am again continuing the division, taking the divisor and the remainder as dividend and divisor, because my remainder is not equal to 0. I got the remainder as 6. That remainder is not equal to 0. So, I have to continue the division until I get the remainder 0. So, 12 and 6. How many times? 2 times 12, 0. I got the remainder 0. Here how I will write here the general form. 12 equals 6 into 2 plus 0. Here r equals 0. So, division process is over. Then the number with the quotient or the divisor. What divisor we got here as per our equation? 6. That divisor will be the HCF of these two numbers, 6. Before we did it by factors, by factorization, we have found out that the HCF of 12 and 18 is 6 by doing factorization. But now with Euclid's division lemma, we found out that the HCF of 12 and 18 is 6. The HCF will be the number here with the divisor here as per our general form. That will be the HCF. Here 6. So, HCF of what number? 12, 18 equals 6. HCF of 12 and 18 equals 6. Clear? HCF of 12 and 18 equals 6. It is equal to HCF of 12 and 6. HCF of 12 and 6 also will be 6 only. Right? HCF of 12 and 18 is 6. Same way HCF of 12 and 6 also will be 6. We are doing the same division procedure here also. So, both will be equal. Equals 6. And this is what Euclid's division lemma is. Okay. We will write all steps. Then we'll do some other problems and it will be more clear. Okay. Okay children. So, Euclid's division lemma is, using Euclid's division lemma, we'll find out the HCF of two numbers provided A should be greater than B, A equals BQ plus R, and if R equals 0, then HCF is B. B means our divisor. And if R not equal to 0, then we have to apply Euclid's division lemma to B and R. Then again the same process repeats until we get the remainder 0. Then the HCF will be the divisor. Every time we can write it in the general form, then it will be very easy to get the HCF of two numbers. I hope this is clear. Okay. Okay, we'll do one problem. Listen children, this is our first problem. Find the HCF of 455 and 42. Okay, find the HCF of 455 and 42. We'll do it with our Euclid's division lemma. First, what you have to find out? First, what we will do? Okay, we will write 4 HCF of 455 and 42. by Euclid's division lemma. Let's take this will be the dividend and this will be the divisor. So let's take A equals 455 and B equals 42, and the general form is I will write it on dividend equals divisor into quotient plus remainder, okay, which is equal to A equals B into Q plus R. First, what we will do, we are going to divide 455 with 42. We are going to divide 455 with 42. Okay, how many times? 10 times it will come 420. Remainder what we will get? 35. Okay, then we can write it as how? 455 equals 42 into 10 plus 35. 42 into 10 plus 35. Here the remainder is not equal to 0. Here R equals 35, which means R not equal to 0. Then what we have to do? We have to again do the Euclid's division lemma by taking 42 and 35. 42 the divisor and the remainder. Now the divisor will become the dividend. So again we are going to divide 42 with 35. Once 35, how much? 7, right? Then I am again going to write the general form. 42 equals 35 into 1 plus 7. Here also what you have noticed? R is not equal to 0. R equals 7. Then what we have to do? We have to again do the division by taking 35 and 7. How we will do? We are going to divide 35 with 7. How many times? 7 5s are 35. Now what we got? We got remainder 0. That means the division process is finished. We got the remainder 0. Now I am going to write 35 equals 7 into 5 plus 0. Here remainder is 0. R equals 0. So what will be the HCF? HCF of 455 and 42 will be the divisor here. What is that? 7. So HCF of 455 and 42 is equal to 7. We got the answer. HCF of 455 and 42 is 7. I hope this is clear. To find the HCF of two numbers, we can use Euclid's division lemma. The steps, the general form is A equals B into Q plus R, where A is the dividend, B is the dividend, divisor, Q is the quotient and R is the remainder. What we have to do? We have to take the biggest number from the given two numbers, make it as the dividend and the other number as the divisor. We have to divide 455 with 42 and we have to check whether the remainder what we got is 0 or not. If the remainder is not equal to 0, we have to again continue the division by taking the divisor and the remainder as the A and B, that is dividend and divisor, until we get remainder equals 0, that is HCF of. Then if the remainder is 0, then what will be the HCF? HCF will be the B term. B term means the divisor. As per our equation, A equals B into Q plus R, this B will be the HCF of those two numbers. Is it clear? You can just note it down and we'll come with more problems. Then it will be very clear. We'll do some more problems, then the concept will be very clear to you. This is not a tough thing, it's very easy. Just you need a little bit understanding of the concept, then it will be very easy. Okay, children?